Let's do a recurring decimals problem. So as with all recurring decimal problems, the first goal is to figure out what did the dots mean. So in this problem, where the dots are positioned above the 4 and above the 6, that means the 4 and the 6 are going to recur. Right? If the dots were positioned above the 1 as well, then it would be 146, 146, 146, or even if it was 146, it would mean everything after the 1 recurs. But in this case, we're talking about 4 and the 6 recurring. So I'm going to write it as x is 0.1464646, etc. And then I'm going to do 10x, just to multiply it by 10, and do 1.464646. And then I'm going to do 100x is 14.46, 64646, and then 1000x. And the reason I'm doing each of these individually is because I want to be able to subtract two of these such that I get a whole number on both sides. So if I do it for this one, if we look at what's after each decimal, for the 10, for the x, the 10x, the 100x, and the 1000x, I want to be able to subtract them such that I'll be left with a whole number. So if I subtract this line from the 100x line, I'm not going to be left with a whole number because what follows the decimal is not the same. Whereas if I subtract the 10x from the 1000x, I'm subtracting 46 and I'm subtracting 46 as well, which means I'll just have whole numbers on both sides. So we're going to rule out doing the 100x, and we're going to have 990x, where I've subtracted 10 from 1000. And we do 146, but don't forget the 1, so we're actually going to have 145. And then we're going to divide by 990, and that simplifies to 29 over 198, which indeed gives us this if you put it into your calculator. So the final answer here will be 29 over 198.